world continues to grow. Energy consumption continues to grow. Many predictions have energy use on the planet growing by 50% by 2030s, 2035 or so. That power has to come from somewhere. And continuing to extract the Earth's resources, to burn coal, to burn products to create that power is not a long-term solution. At some point, there'll be diminishing returns. We will be running out of those resources, and the cost to the environment just becomes too high. The world, though, has plenty of energy in renewable power, be it hydro, wind, and solar. Solar is a great resource to help meet the world's needs, delivering power when and where it's needed.
Solar's been around since the Roman Empire. They have heated water with solar for a long period of time. But photovoltaics, or semiconductor devices that convert sunlight into electricity, have been around since the 50s in very low efficiency. And then really solar's kind of come into its own since the late 90s, early 2000s in a scale that's made it cost competitive.
Arguably, solar power started to become cost-effective for commercial use probably in the mid-90s at a relatively small scale, mostly in Europe. As each year goes by, all of the technologies get better and less expensive. The technology we use at Amonix, CPV technology, promises to be the least expensive and the highest energy-producing technology yet seen. Amonix has its research and development facility in Torrance, California, so there's a team of engineers here that works every day to find new ways of making our systems better, which means higher performance, more reliable, more durable, and lower cost. So we experiment with different ideas and come up with new ways of improving the system, the optics, the solar cell, and integrating the two in a tracking system that will work better in the field. CPV stands for concentrator photovoltaics, and it's different from the technology most people are familiar with, which is just PV or photovoltaics, in that it uses optics to concentrate light down onto relatively small solar cells. With PV, large sheets of semiconductor are laid out and are used to both collect the sunlight and convert it into electricity. With concentrating PV, CPV, we separate those two things. And so we use relatively inexpensive acrylic lenses to collect the light, and then those lenses are focused down onto small pieces of semiconductor that then convert the sunlight into electricity with very high efficiency. And by separating those two things, we can do a lot more in terms of optimizing light collection and energy conversion. It also enables us to track the sun because the optics need tracking to operate. We build tracking systems. The high energy of the solar cell can be used and pays for that expensive tracking. So we can now build a system that tracks the sun all day long in an economical fashion. And so we generate not just power at a brief period of the day, but actually all day long.
The environment that concentrating PV thrives in is one where there's a high percentage of the days that have direct sunlight. And by direct sunlight, what I mean is if you're casting a shadow, there's direct sunlight. And if there's direct sunlight, CPV's performing exceptionally well. So the areas of the world that have a high number of days of direct sunlight are typically the arid regions of the world. So those are all regions where CPV is going to be a better choice than conventional PV or concentrating solar thermal for the generation of electricity from solar. Our systems have a very positive impact on the environment and minimal impact on the environment where they get installed. So first, the systems generate no carbon dioxide in the generation of power. Secondly, the systems use no water in the generation of electricity, which is untrue of virtually every other generation technology. And thirdly, the systems are pole mounted, so they sit atop a big pedestal, and that pedestal uses up very little ground, so it enables the land to continue to be used for whatever purpose it was being used before. So we have installations where animals graze, we have installations where plants are grown, and those type of land uses can successfully coexist with solar generation when you use an Amonix system.
Amonix systems deploy very well on many types of land that might be unsuitable for other uses. Reclaimed land to active quarries, mining sites, old industrial sites. We don't need a big contiguous piece of land to deploy. We can deploy in and around existing infrastructure very, very efficiently, and that gives us a great advantage to get a high energy density from lands that might not have much marginal use. Amonix technology moves installation from the field to the factory where it can be done in a controlled environment, be done with great accuracy, great reliability. Amonix systems deploy in 19 pieces for a single pedestal. That pedestal produces 60 kilowatts or more of energy. A competing solar technology might have hundreds or even thousands of pieces being installed in the field. That increases installation time, it increases installation complexity, and importantly, Amonix systems deploy much like wind. The United States has a very, very long history now installing wind, and there are very strong, reliable, developed wind installers that know how to do wind well. That expertise, that knowledge built up over time is translatable directly into Amonix systems.
Today we have two factories under Amonix where we actually produce the product. The first factory, which was our original manufacturing site, is in Seal Beach, California, where we produce the mega module. All the components that go into this are produced in Seal Beach, California, from the package itself that holds the cell all the way to the end. Our newest factory in the city of North Las Vegas in Nevada produces everything that you see here in this factory other than the packages. That is, from the plates to the mega modules are manufactured there.
Jobs and cheaper electricity bills are coming to the valley.
A California-based company is getting ready to put hundreds of southern Nevadans to work.
The company's called Amonix, and it makes panels that can produce 308 kilowatts of electricity.
Senator Reid, a busy guy this weekend. He flipped the switch today at a new solar power facility in Henderson.
This manufacturing plant is really significant. What we're doing is hundreds of jobs. These hundreds of people will be working here. We have a lot of things going with green energy in Nevada.
A solar power company called Amonix received a roughly $6 million tax credit for a new facility they're building in the Las Vegas area. A tax credit they were able to match with roughly $12 million in private capital. That's happening right now.
Amonix manufactures its product in the United States as opposed to China for a couple of different reasons. One is this is where the company is because of the size of our product line and the weight that it carries. It does really not buy you much to produce this in a quote-unquote low-cost region and then spend a lot more money transferring that product from that region into the United States. The other reason is we are an American company. We're proud of the fact that we could generate and produce local jobs.
Solar power is one of the many clean energies we are developing today that can give us a chance to not only clean up our environment, but produce jobs and actually reinvent U.S. manufacturing. Much of what we do at Amonix is an area of solar technology in which the U.S. continues to lead the world, and this can be a new manufacturing industry for the U.S. so it can help our economy, and again it can help produce a cleaner environment and help us reduce the challenges of climate change.
From the moment one, I wanted to make an impact and make a difference because it wasn't okay with me to go dabble with solar and be me too. Because I've been an entrepreneur my life. I want to invent something that could be the dominant force and changing. It's a game-changing type of technology. So that my vision was, how could I go make this one accessible to the masses? So I had to bring the cost down. And I said, I'm very good at that one. Let me go do it. And that's what I started doing.
Amonix started out making systems using silicon cells, and the system worked. It produces a lot of power, and it's a very big system which tracks the sun all day. By changing from the silicon cell to the multi-junction cell, Amonix was able to produce a lot more power from its system. It was one of the first companies to do this. And so by producing more power from the same system, we're able to more than justify the cost of tracking, which is very important for being able to generate energy all day long.
Higher efficiency solar cells did not exist in the 1990s, but they became available in late 1990s and in the early 2000s in the form of space applications. Usually lots of things over there start with the space application because in the space they need much lighter and much higher efficiency cells to generate lots of power because the payload to take it to space is very expensive. So lots of money went from the Air Force, from everybody else, to put lots of money into coming up with much higher efficiency solar cell. And that's what gave birth to what we call multi-junction solar cells. And what multi-junction solar cell does basically utilize the solar spectrum much better, because silicon converts only the visible light. Whatever light you see, that's how much silicon converts into electricity. But light has more spectrum. You heard about UV, and you heard about infrared, underred, and this multi-junction, it means that you have many junctions that tune to those different spectra, therefore, and could bring it all together and absorb that and convert it.
Amonix provides the highest efficiency solar systems available today, with a 40% cell level efficiency, a 30+% module level efficiency, and a 25% grid deliverable post-inverter efficiency. That means an Amonix system is delivering to the grid 25% of the potential available sunlight hitting an Amonix system from dawn to dusk. This is far, far different than other solar technologies. For comparable numbers, our 30% would compare to a thin film number in the 11% range and a traditional silicon technology in the 14% range.
Amonix systems are absolutely proven in the field. Amonix is a 20-year-old company. We've had systems in the field for 15 years, and now we're on our 7th generation of the product. So this is really important because power plants built with Amonix equipment are typically owned by banks and different financial institutions. And these institutions want to know that the product they're buying works. And if you can't demonstrate with data that your product works, it makes it very difficult to finance. So having the long track record and 15 years of perfecting the art of concentrating light makes a very big difference to the banks that finance these systems.
I think solar technology has enormous potential. That's why I'm here. The sun does not always shine. It doesn't shine at night. But it could easily produce, say, 30% of the world's energy needs. As we convert more of our energy generation to electricity, we can then run electric cars off of the sun. And so the potential for solar energy far exceeds anything we're doing today. And over the next several decades, we could begin a wholesale conversion of solar that could make it 30% of everything we use. With storage technologies that are becoming available, it could rise above 50% before 2050.
I think solar has the potential to resolve a lot of problems we have with society today relating to energy. So it has the potential to give nations back control over their energy supply. It has the potential absolutely to meet much of our energy needs on a daily basis. And when you combine solar with the various energy storage technologies that are right around the corner, mostly batteries being driven by electric vehicles, solar has the potential to meet most of our energy needs. And as the costs have dropped, I think you'll see it increasingly displacing fossil and traditional forms of energy generation very rapidly over the next decade.